Hi everyone, my name is Marie, and like many of you, I love to explore how technologies make our lives easier, but in this case, greener. So when we talk about observability, like you've attended yesterday's session and this morning, and we always talk about observability in terms of APIs, distributed systems, servers. But in this talk, I'm actually going to share how I taught my 8-year-old daughter the concepts of monitoring and observability and how they kept our houseplants alive. So, with that said, welcome to Observability Made Simple, monitoring plants with IoT and Grafana. So first things first, who am I? So I work as a senior developer advocate at Grafana Labs. So we're the company behind open source projects such as Grafana, Loki, Mimir, and Tempo. As a senior developer advocate, if I can sum up my role, is to basically I get paid to learn cool stuff and share those learnings with the community. Before transitioning to developer advocacy, my background has been predominantly in software testing. I'm the co author of the book Contract Testing in Action. So, if you want to know more about contract testing, please support and buy our book. So, you can do that by scanning the QR code here. I'm also a mom of two kids and two dogs, so household life can be pretty chaotic, but obviously rewarding. So if you want to know more about what I do, you can also look at testingwithmarie.com. So our story begins with this plant. And at first glance, taking care of a plant looks and sounds simple. Just give it water and light, right? And that's it. The houseplant should live. But as many of plants don't always make it. And I know I'm not the only one who's done this, so I'd like to see a quick show of hands. Who here has ever killed a houseplant before, and don't lie? Okay, see? Not just me. Okay, so reality is plants die, and it could be from too much water, it could be too little, it could be lack of light, it could be that the room was too hot or too cold. We never know. So I wanted 2025 to be the year of no plant casualties. So I teamed up with my 8-year-old daughter to look after our plants better. But also, I had a secret mission. So I wanted to take this opportunity to teach her more about STEM and make the learning fun along the way as well. So we made a beginner level project that will monitor the soil moisture of our plant and let us know when to water them. And I'd like to share all of that with you in case, you want to try a fun IoT project at home. So as a parent, I wanted her to learn more about what I do for work all day. I've tried explaining it to my parents and explaining things to an 8-year-old what I do for work. She doesn't understand. So I actually watched this talk online from the Grafana YouTube channel on how this parent explained Grafana to his children to IoT home projects. And I was really inspired by that. So I wanted to explain tech concepts using easier to understand terms that are outside the typical technical jargon. So for this part of the talk, I want to focus on how we can explain concepts such as IoT, monitoring, and observability to our kids, or even to anyone who doesn't have much knowledge about it. So using gardening analogies, I asked my daughter to imagine that each plant has a little helper called a sensor. The sensor is in the soil and it could detect moisture levels and inform us when it needed water. So I explained that IoT or Internet of Things is simply just that. So it's a way to connect objects, including sensors, to the internet so they can monitor, they can communicate, and in some cases even take action automatically to make our lives easier. So what's monitoring? So again, explaining things to a non-technical kid, it's very hard. So I explained to her that, okay, think of monitoring as a way to keep an eye on our plant. So we basically monitor the soil's moisture level, and if it's dry, we need to water it. So we're reacting to the situation and we're reacting to the plant's needs. Now, monitoring is useful, but it's limited because it only gives us a yes or no check. If our plant is still unhealthy after watering the plant, monitoring can't really provide us that answer. And that's where observability takes monitoring to the next level. So I explained to her that observability allows us to understand why our plant's health changes over time. So for example, Does the soil moisture drop during a specific time of day? Do we need to include other factors such as measuring the room temperature or the humidity? Or could it be something else? Could it be that one of our dogs are doing something that they're not supposed to do? So it's about looking at all the data, identifying patterns over time, and then predicting what's going to happen next. So this is an image that I showed to her just to try to explain what happens if there's no observability. So without observability, essentially you're walking into a room blindfolded. You know that the plant is struggling, but you don't know why. You're essentially guessing and operating on some hunches instead of actual facts. If we add observability in the picture, the black box can become a clear box, and we also have signals. If we have soil moisture signals, it can tell us when to water the plant. If we have light level signals, it can tell us if the plant is getting enough sun. So basically, with observability, we can see the signals clearly, and we can take an action before the plant suffers. So now that I've explained the key concepts to her, the next part is to actually build the project. As I mentioned, this is a beginner level IoT project, so I'm only going to cover the soil moisture sensor. But if you're an IoT enthusiast, if you want a more complete project, you obviously need to look at buying more IoT sensors such as light sensors, temperature, and humidity sensors. Okay. So, on a more technical aspect, how do I explain this soil moisture sensor to her? So, the way I explained it was, our soil moisture sensor is like a fork with two metal parts. So, when the soil is wet, the water helps electricity flow easily. But then when the soil is dry, electricity can't really flow well. Now, the soil moisture sensor processes this information as electrical signals. We have our development board here, and I explained that it's basically the brain of this project. It basically acts as the brain that processes all the signals in terms of the sensor values. Once the soil moisture sensor is connected to our development board, it can have two possible outputs. The first output could be an analog output, and that output could be a variable number depending on the moisture level. So if it's a high number, that means the soil is dry. And if it's a low number, that means that the soil is wet. Or the output could also be digital. So it could either be high or low. And then the output is then visualized to a dashboard using tools such as Grafana, so we can track them over time and make further observations. There were a few bits of hardware that I had to purchase for this project. So I already spoke about the soil moisture sensor. We also had to buy a development board. In this case, we just purchased an ESP32 DevKit development board, but you can use other boards as well. We had to buy a breadboard just to plug everything, all the components together and make it more stable. Some wiring or DuPont cables to connect the sensor to the actual board. And then a USB-C cable, a data cable to connect the board to my laptop. For the software, I also had to install Arduino IDE. So for those of you who are not familiar, Arduino IDE is an open source software, so you can use it to write, to edit, and upload your code to a development board. And then we also had to sign up to a Grafana Cloud account using the free forever plan just to help everything get started easily. Okay. So now that we have everything that we needed, it was time to piece the hardware together and get to the most exciting part of the project. So our first step was to connect the soil moisture sensor pieces using the DuPont cables. Afterwards, we attached the ESP32 development board to the breadboard, and this was an optional step. You can obviously not purchase the breadboard, but in our case, we found that it made everything more stable. Next, we connected the soil moisture sensor to the development board by connecting the following pins. So we connected the VCC pin to 3.3 volts pin, the ground pin from the soil moisture to the ground pin of the development board, and then AO or analog output pin to pin number 11. So just to explain these concepts to her, I said that VCC is basically the power supply. So it's where electricity comes from. It's like the plus side of the battery. And then the 3.3 volts pin, that's the power output on the ESP board. And then ground pin is like the minus side of the battery. So this is where the electricity goes back. And then because we're gonna use analog output instead of digital output, we could just connect it to different pin numbers. And then in this case, we just use pin number 11. So we finally inserted the moisture sensor directly into the soil of our plant, and we connected the board to my laptop via a USB-C cable. Hardware bits are all done. Now it's time to program it. So in Arduino IDE, we obviously added support for our ESP32 board. And then just to keep everything simple, we added this very simple program. So first, we define the variables for our sensor pin and sensor value. Within the setup function, we initialize the serial communication at a 9600 baud rate. She was a bit confused with this, so I just explained to her that imagine you're talking and this person said that you can only speak 9600 letters, and if you speak more than that, they're not going to be able to understand you. Within the loop function, we are basically continuously reading the analog value that's provided by the sensor. And then our logic is if the sensor value is above 500, that means that the soil is dry. And if the value is less than, then the soil is wet. And then we just added a delay of 5 seconds before taking another reading. After uploading the code to the development board, we opened up the serial monitor in Arduino IDE, and we saw the following messages, which is a good sign. That means everything is working. And at this point, she thought that we were finished with the project, but I told her we can't keep looking at logs in Arduino 24/7. So the next part of the project was to teach her how to send the sensor values to Prometheus. The next challenge for me was, okay, how do I explain Prometheus to an 8-year-old? And obviously not this Prometheus, but this Prometheus. So I asked her to imagine that Prometheus is our gardener. So this gardener collects the sensor values continuously and stores all of them in a toolbox, and that toolbox is called a database. Prometheus can store other metrics as well, but for our example, Prometheus will only collect these sensor values from Arduino. The database that Prometheus is using, I explained to her that it's called a time series database. So this means that Prometheus keeps track of when the values are stored, so it will also keep track of the timestamp so that in the future we can see a timeline of how the sensor values change over time. Now, how do we actually get back the sensor values from Prometheus? And I told her that you must do this, but if you have to speak other language, obviously Prometheus will understand, so you have to speak its own language, which is called PromQL or Prometheus Query Language. And a query can look like this. So it consists of the metric name. In this case, our metric name is called soil moisture. And it can also have an optional label filter. So this label filter will only return values based on what we have provided. Now, how do I actually show her the Prometheus in terms of the setup? And the easiest way for me to do that was to use the fully managed Prometheus instance that we have in our Grafana Cloud account. So in Arduino as well, so the image on the left, we also had to install additional libraries such as the PromLoki transport and the Prometheus Arduino just to help us send the sensor values to Prometheus. And then the next step was to actually store the Prometheus instance in a configuration file so that our Arduino code could actually connect to Prometheus. And here is just an example snippet of code. But essentially, we needed to provide the Prometheus URL, the username, and the API token, as well as Wi-Fi details so that Arduino can actually send the data. And then we also had to include a certificates file. So for Arduino to have that secure connection with Grafana, we added this file, which was copied from the Prometheus Arduino GitHub project. There's also a code example of how to send the actual metrics to Prometheus. So instead of reinventing the wheel, we just copied that code example. And I remember she asked if that was cheating. And I said, no, that's just normal when it comes to programming. We just had to tweak it a little bit. But if you want the full project, you can have a look at the plant monitoring GitHub repo for all the details. I have a QR code later as well. So if you want to try this at home, you can go and scan that. And then after uploading the updated program, we saw the following logs, which was a good sign. Now, humans, we basically process images better than words. So how can we then make sure that everything looks clearer in terms of the actual information? So the final piece of that project was to visualize all our Prometheus data to Grafana Cloud. While Prometheus was our gardener, I explained to her that Grafana is this really cool visualizer that takes the sensor values from Prometheus and turns them into beautiful graphs, just basically making those values easier to understand. Within our Grafana instance, we started by creating a new dashboard. And if you're not familiar with Grafana, a dashboard is simply a collection of one or more panels. So a panel can display a specific visualization type. That could be a var graph, a table, or a gauge panel with data being pulled from a data source. And in our case, the data source is the Prometheus instance, and the query is basically the query that you saw a while ago. In terms of the visualization types, we were spoiled for choice. We had the freedom to build the dashboard the way how we wanted it, and we ended up with something like this. So our dashboard was a collection of multiple panels, all using Prometheus as the data source. And in terms of the individual panels, we use a text panel at first. So this is just a simple HTML code that basically add the image of our houseplant. We also use a stat visualization. So if you want to show single values instantly and if you want to show information quickly, then a stat visualization is a good option. So in this case, we wanted to show the plant's health status at a glance. The next panel is the gauge visualization. So a gauge visualization is ideal for when you have clear thresholds. So in our case, we have a threshold that if it's over 500, that means the soil is dry, and if it's less than, the soil is wet. And then finally, we also use the time series visualization. So in Grafana, time series is the default and primary way to display data points that change over time. And then here's what our dashboard looks like if the soil moisture values are above 500. So if you notice, the color of our stat and gauge visualization changed from green to red. And we were able to achieve that easily with Grafana using value mappings. So value mappings in Grafana are basically used to convert raw data values into a much more meaningful or user-friendly text. So it could be an icon, it could be different color. So at least you have a much more clearer value that you want to display on your dashboard. This way, she was able to understand the dashboard clearly and when to water them. Having a dashboard to look like is an excellent idea. But in theory, I'm not going to look at our dashboard all the time. So we thought that setting up an alert when our plant was thirsty would be even better. So we actually configured alerting in our project. And to set this up, we simply created a new alert condition that says when the query is above 500. So this basically ensures that we would only get alerted if the soil moisture value was above this value. And then the Prometheus query is basically the same query that you've been seeing. We created a new contact point as well. So a contact point in Grafana is basically who should receive that notification when that alert rule is triggered. So in our example, we chose Telegram. So every time the sensor value goes above 500, I would get the following notification, and I would then tell her, Gabrielle, it's time to water the plant. And then finally, everyone's been talking a lot about AI these days, so let's jump on that wagon as well. To enhance the look of our dashboard, we also played around with Grafana Assistant. Grafana Assistant is basically an AI-powered agentic LLM, and the integration is built directly into Grafana Cloud. So here, you can see that I simply ask Grafana Assistant if can you make visual enhancement just to make the dashboard prettier. And now you can see that the dashboard looks really good now. It looks really professional. Some takeaways. So just to close this session, here are some takeaways from doing this project with her. Learning about monitoring and observability is fun. So by using gardening analogies, I was able to explain these key concepts to her in a playful way. So, what I want you to all do to encourage you is to explain technical stuff to one another more often, whether that's at work or at home, in a fun, non condescending way. Getting started with IoT and Grafana is great for STEM learning. So after this project, we're going to look at adding a automated watering system, and we're also going to start other IoT projects as well. This way I can support her interests to STEM subjects. And finally, our plants are healthy. So if you want all of the info, so the GitHub projects, like the actual code, how to set up Arduino, everything's there. So just scan it and it will give you all the important links. And that is it. Thank you so much for attending my talk. If you have any questions, I'm happy to answer them. But if you also have questions specific to Grafana, you can join us at community.grafana.com. And yeah, you can connect with me as well on LinkedIn. Thank you.
Questions?
Oh, and we have some stickers here. So if you want Grafana stickers, yeah, there's loads.